Hello students, in this session let us solve this question of bending equation. In this question it is given that a cantilever of length 2 meter fails when a load of 2 kilonewton is applied at the free end. If the section of the beam is 40 by 60 mm, find the stress at the failure. So it is again the question of bending stresses where there is a cantilever. The length of the cantilever is 2 meters and the load applied is 2 kilonewton. It is the maximum load which can be applied at the free end. The cross section area is 40 by 60 millimeter square and we have to find the stresses when the failure takes place. So let us solve this problem. In this question, we are given with a cantilever beam of 2 meter length applied with 2 kilonewton point load at the end. We have to find the maximum stress developed in the material. Sigma max we have to find out, right? So you know that the stress depends upon the bending moment, right? So you should know the bending moment diagram of this cantilever beam. Go to your shear force bending moment diagram and find out the bending moment diagram for a beam at which a point load is acting. You can take a section and find out. You will find that this is a bending moment diagram of this beam and you will get the maximum bending moment at this point, and that is WL. That is the WL, where W is the load which is placed here and L is the length of this beam, L, right? And this is negative, but doesn't matter, negative positive is our sign convention basically. So this is the load, this is the bending moment obtained at the end. So the stress will be maximum where the bending moment is maximum, and the stress is at outer fiber. You know that from the neutral axis at the outer fiber the stress is maximum. So stress will be maximum where y is maximum, the vertical distance y is maximum. Remember the formula, m by I equal to sigma by y, right? So the point where y and m is maximum. So sigma max will be equal to m y by I. So both maximum, m as well as y. So m max and y max, right? So this is the sigma max, right? And you will get the maximum stress at the outer fiber. So this is the stress condition. This is the stress condition, like this. You will get maximum stress at the outer fiber, like this, right? This is sigma max. On one side it will be compressive, on another side it will be tensile, but it will be maximum, and at this point, at this section it will be maximum, at this section it will be maximum, right? And at outer fiber, at the outer fiber means either at this point or at this point, right? This will be maximum, right? Because the bending moment is maximum and again y max. So sigma maximum we will take m is WL, this is WL, multiplied by y max. Y max is basically the d by 2, the maximum fiber, right, from the neutral axis, that is d by 2, where d is 60 mm. Dimensions are in mm. Here d is 60 mm and b is 40 mm, right? So WL d by 2, I is the moment of inertia of this beam, cross section of the beam. So that is BD cube by 12. So BD cube by 12. Solve it, you will get, what you are getting is WL by 12, 6 WL So it will come out here 6 WL by BD square, right? This is the value 6 WL by BD square, and 12 will come in the numerator and 2 is in denominator, so 6, right? So 6 WL by BD square. So sigma max, put the values and you will get the final answer, that is 6 W. W is the load applied, that is 2000 Newton. L can be taken in millimeter, so it can be taken in millimeter, so that answer may come in megapascal, divided by B, width, that is 40 mm, take it in mm 40, D square is depth, that is 60 square. So finally you will get the answer in megapascal. The maximum stress in the material, that is 166.67 megapascal. So this is the maximum stress in the material, that is 166.67 megapascal. So this is the answer of this problem, right? So we have applied a load at the end and obtained the maximum bending moment at the fixed part, right, where there is this cantilever beam is fixed, and which is given by WL. So we have obtained this formula, M max Y max by I. M max is WL at point A, Y max is the outer fiber of the material, that is D by 2, and this is the moment of inertia of the material, that is BD cube by 12. Solve it, you will get this answer, the maximum stress in the material.